Warning: the video you're about to watch contains mathematics at the level of pre-calculus. All material has an assumed prerequisite of college algebra and trigonometry. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is a continuation of sequences and series, specifically an introduction to sequences. We have already defined what a sequence is. We have talked about recursively defined sequences, and now we're going to start getting into the most important part of sequences for us, which is partial sums of sequences. So what is a partial sum? Well, a partial sum of a sequence is defined as follows. S sub 1 is the sum of the first element of the sequence. S sub 2 is the sum of the first two elements of the sequence. S sub 3 is the sum of the first three elements of the sequence, and so on and so forth. S sub n would be the sum of the first n terms of the sequence. That's it. So that is called the nth partial sum, or if you stop at I, it's called the ith partial sum. But the last one there, since it stopped at n, is called the nth partial sum. The sequence, well, maybe I should make a bigger stink about this. So you have two sequences. You have a sequence A1, A2, A3, and so on and so forth down the line. That's your base sequence. That's what I'm always going to refer to as the base sequence. It's a sequence that everything else is based upon. However, because we can create this sequence of partial sums, S1, S2, S3, S4, S5, all the way down to Sn, or however far we want to go, we have a secondary sequence. And that secondary sequence is called the sequence of partial sums. Sequence of partial sums. This is where it gets a little confusing, I think, for students. The sequence of partial sums is not A1, A2, A3, but S1, S2, S3, and so on and so forth down the line. It is basically just a brand new sequence built from your base sequence, and this brand new sequence is just the partial sums. S1 is the sum of the first element, S2 is the sum of the first two elements, S sub 3 is the sum of the first three elements, and so on and so forth. So this is an important note to consider. Every given sequence is actually two sequences. It is first and foremost just the base sequence you were handed, but then there's a hidden sequence of partial sums behind it. That is critical for you to understand and clarify for yourself from the get-go. That sequence of partial sums is hidden, and it's different than the original sequence. It's actually, in many ways, more important than the original sequence. And that's why I'm just letting you know you have to make that clarification in your head as soon as possible. Of course, we will give some examples. So consider this guy. Find the first four partial sums and the nth partial sum of the sequence. But first of all, ignoring that question, let's go ahead and just showcase what the sequence itself is. A sub 1, let me use my black pen here. A sub 1 is 1/3, and A sub 2 is 1/9, and A sub 3 is 1/27. You could probably guess what A sub 4 is. It's going to be 1/81. You're just multiplying by a third every time. So dot, dot, dot. This sequence just goes on forever. And we could easily find a formula for it. It's 1/3 raised to the nth. You could double check that. If n was 1, in other words, A1 here, it'd be 1/3 to the first. If n was 2, A sub 2, we'd have 1/3 squared. So it does work out. All right, but nobody asked for that in this situation. Now they ask, well, what are the first four partial sums of the nth partial sum, or what are the first four partial sums and the nth partial sum of the sequence? Well, since they're asking for the first four, I should probably have gone down to a sub 4 here. A sub 4 is equal to 1 over 81, and then dot, dot, dot. I'll do the partial sums in green. So the partial sum, the first partial sum is just the sum of the very first element, and that's just 1/3. That's how it's always going to operate. The second partial sum is A1 plus A2. That's going to be 1/3. Write that in, 1/3 plus 1/9. Now this might be helpful to see if you can compress these down, but I'm going to hold off on that for right now. The reason why is that this is a point in mathematics where it's often much better to hold off on simplifying until you see a pattern or until the very end. I'm not going to say that it's a good idea here. I'm just going to say that that is how I'm going to approach it. I'm not going to simplify until the very end. The third partial sum is the sum of A1, A2, and A3, which is 1/3 plus 1/9 plus 1/27. And then finally, the fourth partial sum, which is A1 plus A2 plus A3 plus A4, which again is 1/3 plus 1/9 plus 1/27 plus 1 over 81. Now, if those, when we try to get those glued together, if they don't glue together nicely, then finding the nth partial sums can be very difficult. Let's just see if there is a pattern now. Adding these two fractions together. Now my blue ink is just me doing the arithmetic. Let's see, 3 plus 1 is 4/9. Okay. And let's see, blue ink here. I have 9 plus 3 is 12 plus 1 is 13 over 27. Well, that doesn't really help out. I can see the denominator is 27. So the denominators are powers of 3. These blue denominators are powers of 3. But unfortunately, the numerators are going to throw me for a loop. But let's try this next one. That's going to be 27 plus 9, which is 36, plus 3, which is 39, plus 1, which is 40 over 81. Now, this might be a bit unfair to find a pattern here, but there is a pattern. It's hard to write without something called summation notation, and we aren't going to talk about that as of yet, but I do want to kind of illustrate what you could possibly see here. So notice 4/9 is the same thing as 1 plus 3 over 9. And I'll even say over 3 squared. And if you look at the next one, it's 1 plus 3 plus 9. And again, that's all over 3 cubed. And the next one is 1 plus 3 plus 9 plus 27. Again, all over 3 to the 4th. We'll zoom out here. And without summation notation, which I haven't introduced yet, this will be incredibly difficult for you to see, but I'm going to try to show you. This is 3 to the 0th plus 3 to the 1st, all over 3 squared. The next one. This is 3 to the 0th plus 3 to the 1st plus 3 squared, all over 3 to the 3rd. The next one. This is 3 to the 0th plus 3 to the 1st plus 3 to the 2nd plus 3 to the 3rd, all over 3 to the 4th. And so you could possibly see the pattern. The summation for the nth term, the nth partial sum, should be 3 to the 0th plus 3 to the 1st, whoops, that's supposed to be a first, plus dot, 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 all the way until you get to, now notice the indices here. When the index was 4, we entered the power of 3. When the index was 3, we entered the power at 2. So that's what I'm going to do. I'm going to end the power at 1 less than n. So we're going to add all those up until we get to 3 raised to the n minus 1. And that will all be over 3 to the nth power. And that's as good as you can kind of get right now without summation notation. A very, very challenging problem, but the critical thinking skills are required. Like you should be able to do this. Is it high level? It's not calculus level, but it's close. You'll be doing pattern recognition like this in calculus, so you need to kind of be on that game. Trying to look at it to see if there's maybe another way I could write this without using the summation notation. And truthfully, the only other way I could have written it is by looking at that fourth sum and noting that really all it is just 1 over 3 to the first plus 1 over 3 to the second plus 1 over 3 to the third and then plus 1 over 3 to the fourth. Oops. And you could have written it that way as well. So I don't see a problem with that for you to say, oh, this nth partial sum is 1 over 3 to the first plus 1 over 3 to the second plus ... all the way until 1 over 3 to the nth. You could do that, but in the long run, we'll have a better way of noting that. And I just want to reiterate with that last example that it is going to be true. In the long run, we'll have a nice, cleaner way of doing that. But for right now, I just want to get you used to writing out nth partial sums. This one specifically happens quite often in Calculus 2. You're given this sequence, and you want to know the nth partial sums. Now, you could technically go ahead and write out the first few terms of the sequence if you want to. I think that's useful. So A1 is just square root of 1 minus the square root of 2. A sub 2 is the square root of 2 minus the square root of 3. A sub 3 is the square root of 3 minus the square root of 4. And A sub 4 is the square root of 4 minus the square root of 5. Notice I didn't write the square root of 4 as 2. I just didn't want to. And by the way, a sub n is obviously the square root of n minus the square root of n plus 1. Now let's use green for the nth partial sums. The first sum is 1 minus root 2. The second is going to take that 1 minus root 2, which is a sub 1, and you're going to add to it a sub 2, which is square root of 2 minus square root of 3. And you could see something magical happen. The square roots of 2 cancel, and you get that this is just 1 minus root 3. Interesting. And then the third partial sum, you take A1 added to A2 and add that to A3. Now here's the deal. A1 plus A2, this is true for all our nth partial sums. You could easily just say, listen, I already know what A1 plus A2 is. It's right here. That's A1, that's what S sub 2 is. So I could have, in the previous examples, also done that. I could have said S sub 3 is just the sum of the first two plus the third term in the sequence. And the sum of the first two here were 1 minus root 3. And then the third term of our sequence is a positive root 3 minus root 4. And you get this magical negative root 3 plus root 3 canceling. And you have a beautiful 1 minus the square root of 4. And then you look at S sub 4 and you say, well, I'm going to use that same trick. It's just the sum of the first three elements plus the fourth element in the sequence. Well, the sum of the first three elements we have right here. It's just 1 minus the square root of 4. The fourth term of the sequence is root 4 minus root 5. And so that will equal 1 minus root 5 when everything compresses down because the square roots of 4's cancel. And now I can easily say what the nth summation, nth partial sum is going to turn into. The nth partial sum is going to equal 1 minus, notice when the index was 4, this was the square root of 5. When the index was 3, it was the square root of 4. When the index was 2, it was the square root of 3. So this is going to be the square root of n plus 1. So 1 minus the square root of n plus 1. It's one of those rare moments where you get a formula for the nth partial sum, rather than having to work through like we did in the previous problem and having this big old mess for the nth partial sums. We end up with a nice clean formula in this problem for the nth partial sum. The reason why is because this sequence, the base sequence we were handed originally, this guy right here, is called a telescoping sequence. Well, actually the sum is called a telescoping sum. And what that basically means is that it's like an old pirate's telescope. It extends out for a long distance, but it turns out it just collapses to 2 pieces. 1 and the minus square root of n plus 1. So anyhow, yeah, that's how that works. Now, that does it for this video on partial sums. We will continually use this information, so don't worry, you will get continual practice. The next video will be all about sigma notation or summation notation and the properties of summation notation, so that we can make our lives a little bit easier when dealing with partial sums.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Aims for what they are and work together until you feel at peace. Says, listen close, don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.